Hello folks, Slavo here from TwineWorks, and today I would like to import some CSV data into a SQL database. And not just any CSV data, I've picked a reasonably large data set from the machine learning repository. It's called the Heterogeneity Activity Recognition Dataset, and it's basically recordings of motion sensor data inside mobile phones and wearable watches, recorded when people were doing a set of scripted exercises like walking up and down stairs or riding bikes. Now this data set comes in two portions, two distinct pieces. When you go to the download section, you'd find them separated. One is the activity recognition zip, and the other is the still zip. The still zip is the one that I'm interested in. It contains data of various mobile devices, the accelerometer data especially, when the device is at rest in different configurations, like laying on its back or being tilted to the left or to the right or laying on top. And what we can expect is a zip file that has multiple files in it, one per device, and orientation. And apparently there are 6 columns in each file: creation time, sensor time, arrival time, so that will be 3 timestamps, and the XYZ data of the accelerometer axes. All right, how hard can it be? Let's do this. Let's get that into a database. Now I've downloaded these files already. Let's look at those. So this is the still file that we are working with, and let's have a look at the actual content. So let's look at phone on back, and let's see, there's some iPhone data from a locked iPhone laying on the back. Oh, we have an index column that wasn't mentioned in the documentation. We have arrival time, creation time, sensor time seems to be missing, which was mentioned. And we have XYZ access data. Perfect. Let's look at another file we have here. We have creation time, sensor time, and arrival time, XYZ data, but the index column isn't here this time. What else can we look at? Let's just pick another one. Okay, this one doesn't have any index column, doesn't have any sensor time either, but there's arrival time and creation time. Now the timestamps, they seem to be consistently integers. I think the iPhone was an outlier here because the creation time seems to have a decimal point. Okay, so that's just gonna inform our selection of data types for the table fields. But we seem to have a total of 7 columns, 7 possible columns. It's going to be index, arrival time, sensor time, which is missing in this file, creation time, and the XYZ values. And we have the different orientations, and we don't have a consistent set like the Galaxy tab. The Galaxy tab, pretty sure it was not in the phone on back category. No, so only certain devices are in certain orientations. So it's not consistent in that sense. Oh, and we have another file, the XSense file, which is, I don't think it's that's a watch or a mobile phone exactly. It's some sort of different device, and that maybe explains why it doesn't have a subfolder to go into. A little bit inconsistent in that sense, but it appears in every configuration. So we have this XSense device, which seems to not have a subfolder. And within each subfolder, we might also find more than one file, I think. I'm not getting lucky here, but when I look for, oh, there you go. So this folder has multiple files in there: creation time, sensor time, arrival time. All right, let's get this into a database and see how we're going to do this. Obviously, I'm going to use TweakStreet for that. And let's start with something with divide and conquer. Let's first create a data flow that takes one of these files and puts them into a database, and then continue in finding all the files that we need and calling our subflow for each file that we have. So let's go with that. So we're going to need a CSV input to read any of these files. I'm going to just pick like any one of those, maybe an iPhone one, just to see what we have. Oh, it wants me to save my file, so let's do this. Let's save it as load CSV. And it finds index, arrival time, creation time, and it wants the arrival time to be an integer because it happens to be an integer in this file. Well, first things first, let's make this a relative path so it will work when I decide to move the whole thing. And let's maybe try another file that would have different configuration like this one. Okay, so here we have creation time, sensor time, and arrival time, all of it as integers. Gonna keep this and work from here. I'm just gonna add a field that is a long field for the index column that we know we sometimes have, and I'm gonna map that to the index column there, and then I'm gonna say everything should be parsed as a decimal number as opposed to longs, because sometimes the timestamps are not just longs. The iPhone was an example. So I'm just going to copy this configuration for parsing numbers and then just paste it into these three. And here I'm going to say this is a simple long for the index column. So that looks pretty good. So when I preview this, I'm going to connect a dummy step so there is a data flow and I can preview or run the whole thing and see what kind of data comes through. I'm going to see that the index is coming in as nil. We do have creation time, sensor time, arrival time, and the XYZ, columns. That's good. The index column happens not to be present in the file that I picked. Let's see what happens if I keep the configuration as it is, but just change the file to something that potentially has an index. I think the XSense files, they had an index like this. Let's run this thing again, confirm, and okay, we have our index with sensor times missing. That's fine. The file doesn't have that. All right. So what do we want to do with the data now that we have it? We just want to put it into a database. So let's see, SQL insert. That's what we're going to need. Remove the dummy and say insert the data. Oh, I need to define a database where to put it. I'm just going to use a Postgres instance that runs locally for me, and then I don't need a password to connect to. I should be able to just test the connection. Yep. box. Fine. That's it. And now I can select connection here. So the table I'm gonna call still because it contains data for devices at rest. And I'm going to just input all the fields. Everything that we have in the row stream will go in there. And I'm gonna, or maybe I'm gonna want to rename some of the things. So, okay, first, primary key, I'm gonna call it the still ID, index. Maybe I would call it sample index just to avoid using the word index as a field. In SQL to avoid confusion. And then creation time, sensor time, these are all decimal numbers. So I'm going to go for 32 digits, 12 of them being potentially decimal digits for all the timestamps. And I'm going to use 20 digits for the XYZ columns. I'm going to need something else. We're going to also need the model. We're going to also need the device name. And we're going to use orientation. Going to need that. Something like this. So the model and device will just be coming from here. Like device is going to be the name of this folder, whatever this is. And whatever's inside, the name of this file is going to be the device. Sometimes there's just there's more than one, then this would be the model and this would be the device. So this is how we're going to map this into the database. Alright, do we need something else in this table? I don't think so. Let's just copy that. Run this. Table's been created. Wonderful. But now we're going to need fill the additional field. So the ID is going to be auto-filled by the database. The index is coming in as a field reference. Just renamed it, so I have to remap that. Orientation, model, and device. I'm going to make this parameters on this job. So this flow. When this flow is invoked, I want to give the file name and orientation, model, and device name. I want to pass that in from the outside, and so we're gonna use this here. So it's going to be all strings. File, and for default value, I'm just going to use any valid path, so I can run it with the default value, and it's going to be fine. I can remove that later if I want the job to fail if invoked with default parameters. But for now, I want this to work. So orientation, I'm going to say it's going to be on bottom, on back, more plausible maybe. Then we have model. What are we going to use? Let's use something that's compatible with this. Oh, so this was on bottom, so let's make this on bottom. Model is going to be this, and the name of the device is going to be this. By default. going to make this relative to the file, because why not? All right, file orientation, model, and device. These are the default values. That looks okay to me. Now let's start using those. First, I'm going to need to use it in here, and then I'm just going to transform this into a formula or reference. I'm going to say I need the parameter file in there. And for the SQL insert, I'm going to need the parameters as values inserted into the table. So I'm just going to say, okay, this is a formula, and I'm going to use orientation, model, and device. And I think that should do it. So the table exists. We created it. The file exists. We should be able to just run this thing with default values. This is what is being read in. And we should be able to see some data in our table. Yeah. So we have the correct orientation, model, device, and the timestamps look fine. Accelerometer data looks fine as well. Okay, so we solved the problem of loading one file. I'm going to just make this nice. Say read CSV file and insert into still table. Great. So now if we want to call this thing with different parameters, it's going to read different files with using the metadata that we passed in. So let's create a data flow that takes care of the second part of the problem, namely finding out which files to load and extracting the metadata from them. So let's go with a get files step. Maybe first save this flow so I can make the paths relative again. And I'm going to call it load still. So let's go into this folder and match files in that folder that conform to glob. All CSV files, please. We have no need for a filter. Max left on error. If something goes wrong, I want the step to fail, just in case. And for the output fields, I don't need all of that. I just need the path. And that should give us all the files. It should be around 200 files, a little less than that. Let's run and see if we can actually see them. Okay, we're getting the paths of all the files, all the CSV files. It's 198 files. All of them structured a little bit differently, but similar enough. All right, and let's extract the metadata information. We have the path. What we want is the orientation, the model, and the device name. I'm going to use a calculator to do these calculations. And I would like to work on some real data. So let me reopen one of the flows, the most recent we've ran, and look at the data again. There you go. Let's just pick any of these paths, like this one, and use it as a variable. Let's just call this test subject. This is some static data that I can use to develop my expressions that will extract the information we need. It's a string. I don't need to specify it here, but just to be clean, you can. Let's go next. What I'm going to do? I'm going to declare a variable subject and just reference my test subject here. Later, when I run the entire run and I want to reference the data that's passing through, I'm just going to replace that with a reference to in.path, which is the data that is going through. But for now, I'm going to work on my test subject. So now that I have my test subject in place, I can start looking at the metadata that I want. Probably shorten that a bit, and it will be still similar enough to what I need. Because what I need is these three sections. File name, this folder here will be the model, and this will be the orientation. I'm just going to drop the phone prefix. So how do we do that? So the first thing I would do is I would just split this path on the separators. On Mac and Linux, this will be /. If you're running on Windows, it would be backslashes here. So the first thing to do is probably just split this path on the separator and then see what we can do. So let's see how we do that. And to look this up, I'm going to check out my docs because I'm going to need the standard library of expressions, and I'm going to need something that there you go, that splits a string. So I can use this. I can use bilateral string, or I can use a splitting function that accepts a regular expression. I'm probably going to do that, and I'm going to split on both the / and the backslash, and that should give me something that is just compatible to work on both Windows and Linux. If I just wanted one platform, I'd probably go with the string split function. Seems easier. But the splitting function, let's see what it does. It wants us to pass in a pattern and potentially a limit. We don't need a limit. We want to split everything. And it returns a function. Okay. Returns a function f, and that function f accepts one string argument and returns a list of substrings split on the boundaries given by pattern. Okay. And we have a couple of examples here. So when we call regex.splitting space, we get a function. This was assigned the value f here, and then when we call that function with some value, it gives us a list where the split has happened. All right. Here's an example of splitting on comma, potentially followed by a space. And if you have some CSV data, then it will remove the comma and space and just give you the payload data. So that's very similar to what we need. So let's go with that. Let's go with that function, regex splitting. Let's go with that. And for that to work, I'm first going to have to comment that in. It's an import that allows me to use the standard library. Let's use that. We're going to get us a function. Let's call the function a splitter, and that splitter is regex splitting on a / or a backslash. That should do the job. Now let's see what it does and whether it does what we need. And so let's see, we're going to go into list, and we're going to get a list of parts in these in this path. So let's call it path parts. I'm just going to copy the formula widget. I'm going to say we're going to call the splitter function with our subject. I'm going to evaluate that, and indeed we are getting the parts of the path. Great. Now we're gonna have to work from the end, and that might be, the last item, the item before that, the item before that, and that could be a bit cumbersome. I would like to work from the front, because I can then use static indexes like 0, 1, 2 to reference the individual parts. So let's see if the standard library can help us. If I wanted to reverse, and there you go. If I wanted to reverse a list, you just call data.reverse on a list. Let's do that. So let's reverse that thing immediately. Oops, data.reverse of whatever comes out of here. And now I should have a list that starts with a file, then the first folder, then the next folder, etc. Perfect. Because now I can extract the parts that I'm interested in. Let's first go for the file name. First go for the file name, and the file name is in the path parts. It's the first entry, so it's index 0. And the device name is going to be path parts, but I want to get rid of the .csv at the end. There are various ways of doing that, but I think I'm just going to go with something that replaces it in the end, like this one. So we have a regular expression to replace something, and I'm going to just replace it with nothing. So I'm going to say regex replacing .csv. Well, strictly speaking, I have to escape this. And this again gives me a function, and I'm just going to call it immediately. So I don't create a replacer function first and assign it a name. I just call it in line with my file name. Let's see what we get. Replace cannot be null. Oh yeah, on the replacing function I have to say what I want to replace it with. Alright, wonderful. The .csv is gone. This is the name of our device. Let's see what we're going to do next. Next, we're going to get the model. So the model is just like one folder up. Alright. So I'm going to say model is path parts 1. So it would be this bit. Let's see if that's right. Yep. And orientation is next. Orientation, I'm going to call it orientation raw because it will still contain the phone prefix, but it's just one folder up. And let's see, let's evaluate all of these things. So we have device, model, and orientation raw. All of that fits. Phone on bottom. And I'm going to use this to calculate the correct orientation. And this time I'm not going to be replacing something at the end, but something at the beginning, namely the phone. And I'm going to be replacing it in orientation raw. Very good. This is this is what I need. So this should already work. Let's see, we have device, model, orientation. Let's put this in order. And evaluate all of these, orientation, model, device, that works. There is still a problem with the orphaned file. That is this. That wouldn't work because there's one folder missing from all of this, and it says model is found on bottom, orientation is still exp. And device is correct, but the other things still don't work. So we have to figure out whether we have one of these orphans passing through, and if we do, then we do something else. So I think the fact that we go 2 folders up and we already at the root of our data source, that should be a good enough hint. So if I go and say is often, I want this to be a Boolean flag, is often as when is true, and going 2 folders up, I end up here. So this often means 2 folders up equals this. And so here it should evaluate to true. If I went somewhere else into a proper file, then this often would be false. Okay, so let's use this and say, where's the orientation? Well, the orientation, if I'm looking at an orphan, it's just 1 folder up. So if it's orphan, then it's going to be 1 folder up. Otherwise, it's 2 folders up. And for model, that will be the same consideration. The model, since there's no model in the path, I'm just going to reuse the whatever device is, the file name, for orphans. So it would be something like, I'm going to copy that expression. If I'm in the orphan, then I'm just going to use the device variable, this one. Otherwise, I'm going to go 1 folder up to get to the model. I think that should work. And we should get sensible results for everything. Let's see. Orientation is on bottom, model and device is correct. Orientation raw is still has the phone prefix, that's fine. Okay, let's go back to regular structure and retest, and it all makes sense. We have good orientation, models, okay, and device has extracted properly. All right, great. Now, what do we want to put into the row stream? Because so far these just have been variables that are populated with values, but nothing actually is emitted into the row stream yet. So let's just reference things from above, and they are available in the scope as vars. So I'm going to say vars orientation. Vars model and device. I'm going to say I'm going to want these things. So now let's run the flow, see what happens. All right, that looks promising. Except for the fact that we're still working with test data. So I have to change the test subject, or the subject of the calculations, to not be the test subject anymore, but instead the path passing through. Let's do that again and see what happens. Alright, so for the accents, we get correct orientation, model, and device, and for the HTC Desire, it's also correct. That looks correct for everything else, so I'm going to say this looks fine. Alright, data looks good. What we now want to do is run our subflow that loads one individual file. So let's configure it to do that. We're going to have to pick the right one. I'm going to have a look at what the parameters are, and now we're going to replace these parameters with values as that are passing through. So this is going to be path, orientation, model, field reference, device. I don't want any output here, and I want this step to fail. If the execution fails, the whole thing would fail. Not doing any error handling. I'm not expecting any errors. But need handling. It's all or nothing. All right. So let's name these things. Find CSV files. Let's call this extract orientation model and device. And let's call this load CSV. And when I run this now, it should load all the files that it finds. And we can see the progress here. And we can see how many files are loaded in real time. Now, one of the things that we could improve here is when running this master flow, I would like to recreate the tables so we don't get duplicate data. Because every time the master flow runs, it inserts everything. And so I don't want to run this twice and have double the data in the database. I just want a clean reload. And so I'm going to use a step here that will recreate the tables. Okay, so in about 50 seconds, all 198 files were loaded. Let's make this a little bit more resilient by prepending the whole thing. I'm going to need to redefine the database here again in this flow. Good. To recreate our database tables, and I think we still have it saved here. The SQL to do this. Still steal it from the other file. Call this recreate tables. And I'm going to prepend the whole thing by saying drop table if exists. Want no output fields. That looks good. All right, let's run this whole thing. It should now recreate the tables. It did, and then load all the files. And once it does that, we should be able to look at the files content in our database. Let's give it a couple of seconds to finish. And done. All right. so now when you look at the database, we have data in, and now we should be able to do some queries to see what it looks like I don't know, maybe look at the availability of data for LG devices. There'll be something like select device, orientation, maybe count of records from our table where the device is LG something, group by device and orientation. And it gives us information about how many records we have for the LG Nexus 4, LG Optimus 2, and the LG G-Watch. It's nice. Maybe another query to figure out the average coordinates when at rest. Also only for LG devices, so that will be something instead of count, we would do something like average of X, an average of Y, and an average of Z. And it shows us for the different orientations where the accelerometer is on average on these devices. All right, so that seems to have worked all right. I'm going to leave the links for the data sources and the video description. And if you want to replicate what I did today, you're going to need at least the preview build 29 of Tweak Street. You should be able to do that. Now, until next time.